Welcome, this is Mr. TG. This is section 9.2 in Algebra 2B. Today we're going to be exploring arithmetic sequences. Up on the top of your notes, you'll see a definition of an arithmetic sequence. It is the difference, it's a sequence where the difference between consecutive terms is constant. The word constant simply means it doesn't change. It's going to always be the same number each time, which is called a common difference. Number one, you can see our common difference as we look here is always 6. Number two, our common difference here is always -3. So we would describe 1 and 2 as arithmetic sequences. Now, we're going to show and demonstrate to you how to set up the two formulas, the recursive and the explicit formula for both of these. Remember, the recursive formula looks something like this. It basically looks at the previous term to establish what the next term in line is. And one thing that's missing here, I'll make sure that you put in, if we were going to do number 1, a sub 1. A sub 1 has to be the first term, which in this case is 5. You always have to establish the first term. Then you simply put in a sub n is equal to a sub n minus 1. Now, a sub n minus 1, this term right here, simply means the prior term. If you're looking at 23, a sub n minus 1 is 17. If you're looking at 11, it's 5. So you always take the previous term plus the common difference. So as you can see right here, this would be how we would write our recursive formula. Always start with a sub 1, whatever it's equal to. So in number 2, we would say a sub 1 is equal to 20. And then we would say a sub n is equal to a sub n minus 1. In this case, we're going down by 3, so their common difference would be 3. That would be how you would express the two formulas in recursive formula form. Now, if we wanted explicit formulas from this, there's a formula also here that helps us do that. So let's erase here a little bit and show you how to establish what we would consider the explicit formula. Now, by definition, the explicit formula basically looks at the term that you're on to create the value. So the first term is 5, the second term is 11, third term is 17. This is probably more meaningful to us because then if I ask you for the 50th term, if you use the recursive formula, you got to extend it out to the 49th term and then find out what that next one would be. It's a lot of work, where the explicit formula, all you have to do is this. In number 1, we would say a sub n equals our first term, which is 5, plus n is the term that we're on, so that stays as a variable, and minus 1, times your common difference, which is, in this case, 6. That would be your explicit formula. If you simplify this algebraically, you would end up with 5 plus 6n minus 6. That's the distributed property. And then last but not least, you would put your like terms together, so you end up with 6n minus 1. That would be the simplified version of your explicit formula. Let's see if it actually worked. If I put 4 in for n, we should get 23. 6 times 4 is 24, minus 1 is 23. If I put 3 in for n, I would get 18 minus 1, which is 17. So you can see, basically, it does work for your sequence number 1. Now I'm going to hit pause. Now I want you to try and come up with the explicit formula for number 2. And don't just hit the go button so we end up passing through this. Try and do it. It's a participation. Is critical that you participate with these videos. So give number 2 a shot and try your best to find the explicit formula. When you come back, I'll have it finished and we'll compare answers. So hit pause at this time. Okay, welcome back. As you can see, I've worked the explicit formula out for number 2. Basically, you take this formula down here and substitute in 2 key values. Your first value, which is 20, and the -3 represents my common difference. So when I substituted that in and then I distributed the -3 out, I got a -3n plus 3, which simplifies to -3n plus 23. Again, always check to make sure it works in case you made a silly mistake. Looking at this sequence, we got 1, 2, 3, 4, 5. This is the 5th term we're on. So that should generate an 8. Well, -3 times 8 is 20. Negative 3 times 5, remember you're multiplying by the term you're on, is negative 15 plus 23 is 8. If I look at the fourth term, negative 3 times 4 is negative 12 plus 23 is 11. So you can see now you can just come up with any term that you want. I could put the 100th term in and it will give me the value, which is very useful when working with sequences. All right, so hopefully that went well. Now the last thing on this page I want to go through with you is called the arithmetic mean. The arithmetic mean is simply the average of the two numbers in an arithmetic sequence. The arithmetic mean can be used to find the missing value of an arithmetic sequence. And what you would do if you look at this, you notice our common difference here is 6. It keeps going up by 6. So I guess you could just use that and find it. That's 19. But if they ask for the arithmetic mean, this is what they're looking for you to do. You would take 13 plus 25. So you add these outer numbers together and simply average them, which is divided by 2. That, of course, would give you 38 divided by 2, which is, of course, 19. And you may ask, why can't I just use the common difference? Well, there'll be problems where you'll just be provided 13 and 25, and you won't know the common difference. So this is the strategy that you need to use to come up with that missing value. Again, it's just an averaging technique, which involves taking the two numbers on the outside and averaging them up to see what that next number in line would be. Now I want you to flip over your notes. On the back page there's a couple problems I'd like to have you work out. I will hit pause, and then when you're done, come back to this video and you will end up seeing how you should have worked these problems out. So good luck with those, and hit play when you're ready to go over those problems. Okay, welcome back. Hopefully you had a chance to complete problems 2 and 3. As you can see in problem number 2, what's a little bit different about that is we're missing 2 boxes, so we couldn't really use the arithmetic mean here to find the middle one, because that would have put us right in the middle of our sequence of numbers. So what I did, as you can see here, is I found the common difference. I noticed there were 3 jumps within my sequence, and then I used the difference between 80 and 125, which was 45, and we divided that by 3, the 3 jumps, giving me a common difference of 15. Once you know what that common difference is, you can just increase by 15. As you can see, that's what I've done. And as you can see too, this should be 115. So 115, let's see, 15 and 80, 95, plus 15, 110, excuse me. So sorry about that. So this one should be 110. And then we end up with 125 as our last term. So here's a problem where we're just looking for the common difference to establish our sequence. If this by chance had one missing box between, I would use the arithmetic mean and just average them like I did in the previous set of notes. Number 3 is a popular question. You'll have to know this on the test, so be aware of this. Hopefully it went well for you, but basically when they start talking about, let me just get this up here, when they start talking about the 80th term, there's no way you're going to use a recursive formula. I don't expect you to write this sequence out 80 terms in it. What you will do though is find a common difference, which we can see is negative 3. Again, you're going down by 3 each time. -1 and -4 is -3. Our first term is -1. If we substitute it into our formula, -1 plus n minus 1 times -3 becomes our initial formula. Simplify it out, you end up with a -3n plus 2 as your explicit formula. And then we put the 80th term in there. One thing you want to always do when you get this formula, it's easy to make a mistake. So let's check it. If, let's say, I put the first term in for n, I'll get -3 plus 2, which is -1. If I put the second term in for n, I'll get a positive, a -4 times -3, which is a positive 12. Excuse me, we're putting 2 in, not -4, 2. So that's a -6 plus 2, which is -4. If I put the third term in, 3, -9 plus 2 is -7. So when you're checking this, don't do what I just almost did. Put the term in. Don't put the value in, okay? And that's what n represents. And so it works. It works for each one of these. So if we put the 80th term in, you're going to end up with a negative 238. Well, hopefully this went well. Let me know if you have any questions, and thanks for watching this video on section 9.2.